In our video today, we're going to look at probability and specifically the theoretical probability, that is the calculated probability of an event. We'll be learning terms such as experiment, trial, outcome, event, and sample space. We'll learn that probability can be expressed as a number between 0 and 1 inclusively. And we'll learn to calculate the probability of a simple event. And of course, we'll know we can do that when we can explain the terms mentioned above, and that we can, in fact, calculate probability of simple events and show them as a fraction. Some key ideas to consider. The term experiment is an activity that produces a varying random chance result. So for example, an experiment might be when we roll a fair dice 100 times. A trial is the single occurrence of a part of an experiment. So example of that might be the single roll of the dice from the experiment above. The outcome is a single result of a particular trial. So the example here might be the numbers 1, 2, 3, 4, 5, and 6 of the dice above. Each of those is a possible outcome. An event is either a single or group of outcomes. So an event could be when we roll the number 1, or an event could be when we roll a 1, 2, or 3. And a sample space is a list of all the possible outcomes for the experiment. So again, using our dice as an example, the sample space are the numbers 1, 2, 3, 4, 5, and 6. They are all the different possibilities. And we often show that, or in fact we do show that by using the curly braces to indicate a sample space. Now, probability, as we know, is the chance of an event happening, and we usually show that as a value between 0 and 1. We can also show it as a fraction or as a percentage. So if we have our number line, if you like, our chance line, where impossible things that cannot happen, are on the far left. We have an even chance, and then we have a certain. So we've seen that in an earlier video. So we could say something that is impossible has a probability of 0. Something that has an even chance has a probability of 0.5, and something that is certain has a probability of 1. So that is our range of 0 to 1 inclusive to show the probability of an event happening. But of course, we can also show that as a percentage. So of course, 0 is a 0%, 0.5 is the same as 50% or a half, and certain is the same as 100% or a whole. Now, if we assume that all the possible outcomes of the sample space are equally likely, then the probability is something that we can calculate. And we show this as the probability of the outcome being the number of outcomes where the event happens divided by the number of total possible outcomes. So let's have a look at this a little bit more closely with an example. So let's say we are rolling that dice. Now the sample space is 1, 2, 3, 4, 5, and 6. They are all the different possible outcomes. Okay? How many are there altogether? There are 6 of them. So 1, 2, 3, 4, 5, 6. There are 6 possible outcomes that can happen in this sample space. So the probability of rolling a 3 is calculated as this, where probability of 3, so we show that as PR with the bracket 3, so that's the event we're looking for, or the outcome we're looking for, is equal to how many times that can happen in the sample space divided by the size of the sample space. So here we have the probability, that's just the abbreviation for probability. That is the outcome that we're trying to calculate. So we look in our list of sample space and we see there's only one number 3 in there. So there's only a single 3. So that's why we have a 1 at the top here. It's the number of times that this particular event can happen in the sample space. And then the 6 at the bottom is the size of the sample space. So we end up with 1 over 6 being 1/6. So the probability of rolling a 3 when we have a dice with 6 sides, the numbers 1, 2, 3, 4, 5, 6 being the sample space, is 1/6. Let's have a look at some other examples. So we have a fair 6-sided dice that shows the numbers 1 to 6. So same as before, what is the sample space? So again, what are all the possible outcomes that we could have? And that are the numbers 1, 2, 3, 4, 5, and 6. Again, we use the curly braces to indicate a sample space. So the probability of rolling a 2, how would we show that? Well, again, we'll write it in the same way. So we have the probability of 2, so PR2 in brackets a little bit below, is equal to how many 2s there are in the sample space. Well, there's only one of them, divided by the size of the sample space, which is 6. So again, the probability of rolling a particular number, in this case a 2, is 1/6. The next one, the probability of rolling a 2 or a 3. So now we've got two conditions that can happen, so we have to look at that a little bit more carefully. So how many 2s or 3s are there in our sample space? There are 2 of them. There's a 1, 2 and 1, 3. So if we write this one out, so the probability of a 2 or a 3, so we've been very careful to show in the little brackets there what is that we're looking for. So if we look at the first part of the equation, we've got a 1 plus 1 up the top. So we're saying there's 1, 2, and there's 1, 3 in our sample space. And then divided by or over the number 6, because there are 6 values in our sample space. So again, we obviously simplify that down. So 1 plus 1 is 2, so we end up with 2 over 6, okay? And where possible, we try and simplify. So 2 over 6 is the same as saying 1/3. Now, if you haven't done a lot of simplifying of fractions, then that's something that you may not understand straight away. So if you just stayed with 2 on 6, that would be fine. It's 2 possibilities out of the 6 possible options. But if you can simplify your fraction, you should try and do so. So 1/3. So the probability of rolling either a 2 or a 3 on any particular roll is 1/3. Now the probability of rolling an even number. So this one, again, same process. We just have to realize what is an even number. So again, if we look at our sample space, the number 2 is an even number, the number 4 is an even number, and the number 6 is an even number. So there are 3 even numbers out of the total possibility of 6. So if we write it out, just like before, so the probability of even is how we're showing it, is equal to 1 plus 1 plus 1 at the top. So again, that's the 1 for the 2, there's a 1 for the 3, and there's a 1 for the 6. They're the 3 even numbers that we have over 6, because there are 6 possible values in our sample space. So again, that becomes 3 on 6. And again, if we know how to, we simplify our fraction from 3 on 6 to be 1/2. So the probability of rolling an even number with this dice is 1/2. We could also say that to be 50% or 0.5 if we wanted to. The 1/3 from the question before is a little bit hard. That's not an easy number to turn into a decimal or into a percentage, but 1/2 is certainly an easy one to show as a decimal or a percentage, being 0.5 or 50% if we wanted to. But we can keep them just as fractions. It's very neat and organised. Let's have a look at a slightly different example. So this one, we have a bag of mixed counters. There are 12 red, 6 green, and 6 blue apparently. So this one, it first asks, what is the sample size? So we've been told how many of each colour we have. So our sample size, we're not looking for the sample set necessarily. We would say that is 12 red, 6 green, and 6 blue. But we just want to know the sample size this time. So it's going to be 12 plus 6 plus 6. So the 12 red plus the 6 green plus the 6 blue, which means our sample size is going to be 24. Now, what is the probability of picking a red counter? So just like before, we're going to look at how many reds are possible in our sample. Then we're going to divide that by the total size of our sample, which is why we got asked the first question. So how many reds are there? There are 12 reds. That's what it tells us up the top. And we know from the first part of the question that there are 24 counters in total. So our sample size is 24. So we've put those bits of information into our formula. So the probability of a red is the 12 possible reds divided by the 24 total possible counters, which again, if we can simplify that, becomes 1/2. So theoretically, in this set of counters, if they're all equal and mixed up properly, etc., then we have 1/2 or 50% or a 0.5 chance probability of picking a red counter randomly out of that bag of counters. PowerPoint hasn't been updated properly. So not rolling, it should be of picking a green. So the probability of picking a green is, again, same formula. We have 6 greens we're told at the top. So it's going to be probability of green equals 6 over 24. So the 6 greens that we know are in there divided by the 24 possible counters in total. And again, if we can simplify our fraction, we end up with a quarter. And again, that could also be shown as 0.25 or as 25%. So it's a nice even fraction that we can turn into a nice even percentage or decimal. So picking a green randomly out of this bag would also be a 0.25 or a 25% or 1/4 probability. And again, in the last one, it should say picking a green or blue, not rolling. So what is the probability of picking a green or blue counter? So a little bit like before, we're looking at both possible options. So here we have the probability of green or blue. So either one is a possibility. So we have 6 green and 6 blue. So in the first part, we can see the 6 plus 6 divided by the 24 possible that we have, which again becomes 12 over 24. So again, if we can simplify that, we have that being 1/2. And again, a half can be converted easily to 0.5 or 50% if you'd like to show them in that way. So again, of picking either a green or a blue, so either of those two colours, we also have a 1/2, 50% or 0.5 probability of picking them out of this bag of counters. In our last example, we're going to look at this a little bit differently, and we're going to use the fact that we know some probabilities to work out a missing value. So here we have a bag of mixed red, yellow, white, and black jelly beans. So there are 4 different colours: red, yellow, white, and black. Now we've been told that the probability of picking a red is 1/4, the probability of picking a yellow is 1/2, and the probability of picking a white is 1/6. Now we have not been given the probability of the black jelly bean. But we are then told that there are 48 jelly beans in the bag. So we need to now work out how many jelly beans there should be of each colour. So again, we got information for the red, the yellow, and the white, but we don't know about the black yet. So we're going to use the fact that we know these probabilities and we know the total amounts, we know the size of the set of values in total, to try and work out how many of each colour there are, so we can then work out the leftover ones being the black jelly beans. So let's have a look. So the probability of red is 1/4. So we know that 1/4 then of the 48 jelly beans have to be red. Okay, so we do the simple math and we will say that red is equal to 1/4 of the 48, which if we put that into our calculator, if we need to, we can find out that that is 12. So 1/4 of the jelly beans must be red, therefore 12 of the 48 jelly beans must be red. We do the same thing for the yellow. It says that the probability of yellow is 1/2, which means that half of the jelly beans in that bag must be yellow. So that means yellow is equal to half of 48, which is 24. So again, the probability of white is 1/6. So again, of the 48 jelly beans, 1/6 of them have to be white. So again, we put that in and we end up with 8. So we know that 12 of the jelly beans are red, 24 of the jelly beans are yellow, and 8 of the jelly beans are white. So now that we've got those 3 numbers, we can work out what is left. So if we take our 48 jelly beans in total, and we take away how many are red, how many are yellow, and how many are white, we will know what must be black, the 4th colour of jelly beans in the bag. So there is our equation: 48 minus the red and yellow and red and yellow and whites added together, which becomes 48 minus 12 plus 24 plus 8 that we worked out on the left-hand side there, which of course is 48 minus 44, which means the leftover is 4. So that tells us that the black jelly beans must make up 4 of the total that we have available. And that's it for this video on theoretical probability. As always, go back and re-watch, look at the terms again, try out the examples, and then head off and do the tasks that you've been set by your teacher.